Time once again for some kitchen table astronomy with Hampshire College astronomer and the head of Kainaat Studios, Salman Hameed, here at your Amherst kitchen table. You were on the Cape last week, luckily because another astronomer became very famous thanks to the Coldplay cam. Oh my word, the name of that company, Astronomer.
Let me hold this article. Okay, so I have real objections to the fact that he's not an astronomer.
I know, and the company's called Astronomer.
And the company's, how can you get a name like that? As for the company, which has nothing to do with astronomy. I mean, it does data work or whatever. And I found out about it because on my Facebook feed, yes, I'm old. I have Facebook. Because I have a lot of astronomy friends on it, and they were all posting about it because it went to them first. And I was like, oh, it must be an astronomer. And I was like, who cares about an astronomer? But it turns out that the company is an astronomer. And for me, that is a scandal.
Yeah. Also, you add Coldplay into the mix.
Oh, my
Come on.
goodness. Yeah.
You know, they hired Chris Martin of Coldplay's ex-wife, Gwyneth Paltrow, to be their spokesperson now after all of this. It's actually kind of funny.
Oh, you mean the company?
Yeah, Astronomer.
And probably it has the same amount of science as Gwyneth Paltrow.
Yeah, exactly. And her goop or what have you. The other big astronomy news is that there are some meteor showers coming up. In August, there's the Perseid meteor showers, but supposedly the moon is going to be so bright that it will be hard to see the Perseid. So according to an article from NPR, which also still needs your support, there is an opportunity tomorrow night, the 29th, and the 30th in particular, where the moon's going to be about 25% full, and you can see the convergence of two meteor showers at the same time, the Southern Delta Aquariids and the Alpha Capricornids, which will reach their peaks on the nights of July 29th through the 30th.
And remember, you don't need any telescope for this.
Yeah, it's just,
you don't need even a binocular for that. Just go out, and you do need an open space,
right?
And so and look for it.
Get away from the lights,
and which our area is actually pretty good regarding that. And just go out and look at the sky. I mean, under normal circumstances, you have about 8 or so meteors per hour. And when there are meteor showers, of course, it ranges because these are the dust particles left over by comets. And so they enter the atmosphere. And so you have an increased, basically our Earth is passing through the debris left over by a comet. So you have an increased number of meteors in there. Sometimes there's more, sometimes there's a lot more.
Yeah, they're estimating maybe as many as 30 an hour. So that's a really good possibility to see them. They're not the most magnificent scientific thing to see in the sky, but they're super fun to see. It's like a fireworks display that nature is providing for you that doesn't scare your dogs.
Plus, just imagine how many wishes you can make.
Oh, totally.
For restoring funding, for example, and things like that.
One more little NPR story. Listening to Wait, Wait, Don't Tell Me over the weekend, and they were making fun of our favorite person to make fun of, who's an astronomer, Avi Loeb, about calling everything he sees in the solar system an alien spacecraft. And I was like, well done, Wait, Wait, Don't Tell Me.
And this is one of those, I thought about bringing it up sort of like to talk today about his claim that the new interstellar comet is also an alien spacecraft. But then I was like, I mean, why give more oxygen to something like this, which he has explicitly said himself is designed to get attention and money.
Right.
And so, yeah, I mean, and again, in the larger context, one way to think about it is, wouldn't it be weird that there are no interstellar comets, like natural objects?
Right.
And so we have found 3, and he thinks that all of them, if you see something that is not from our solar system, it must be an alien spacecraft. That boggles my mind.
But he does get the funding for doing it. So I'll just say right here, NEPM's Jill Kaufman is an alien. So send funding our way.
Right, but we have to be careful, because if you say I am an alien, then I will soon be in Venezuela.
Yeah. Anyway, we are going to talk about immigration.
That's true.
And the stars, but not of human beings.
Yeah, so this is a fascinating story. There's an article that got published in Nature just this past week, and it was about these Bogong moths. These are in Australia, and as it turns out, scientists have figured out that they migrate about 600 miles to another location. So they're born in one place, and then they start their migration in Australian spring, and they go 600 miles to caves over there in the Australian Alps. And over there, they spend the summer, and then in the fall, they travel back 600 miles to the place where they were born. Over there, they reproduce, and then they die. The question is, how do they know where to go for such a long distance? And so that's what people were trying to figure out. And the answer lies in the stars.
Nice.
And so this is, Monty, you and I had talked a while back on your other radio show about the fact that dung beetles, there was a study about them in South Africa, that they use the light from the moon, or the polarized light from the moon, in order to travel in straight lines. So when they are making their dung, they have to go in straight lines. Otherwise, they would run into other dung beetles, and that usually ends up in fights and things like that.
I know that's what's happened to me in similar situations.
And so scientists actually figured out from Lund University that, well, they must use some kind of a method in order to figure out how to go in straight line. And they found out that it was the light from the moon, which is polarized, just like your polarized sunglasses that they use for the sun also. They use that to go through. But they were still puzzled by it. What if there is no moon?
Because there's times where you don't see any moon in the sky.
And it turns out that they use the Milky Way. And that was a fascinating study, and so we know that dung beetles, for example, use the sky, the night sky, to do this. And these are nocturnal dung beetles. And so another group from Lund University, I think it's another group, or maybe it's a similar group, but they actually studied these Bogong moths, Australian moths, and they suspected that in order to go these long distances, about 600 miles, they actually make use of the stars as well. And it's a fascinating study because they had to capture these moths. I mean, to me, the interesting part is, yes, they use astronomy, which is really cool. But there is another component, that how do they figure out that they are using stars? And so in this particular case, they captured some moths. And I should mention that these Bogong moths are they used to be very common in Australia. They're important to the Aboriginal culture as well. They used to eat them, and apparently they taste like, the paste and stuff like that taste like they're nutty, so like almonds and things like that. And in fact, there was some microscopic remains that were found of these in a paste form, which was 2,000 years old.
Wow!
So it's actually really interesting component. And there is a region or a mountain range which is also called Bogong, or Mount Bogong, because of the moth, not the other way around.
Yeah, nice.
But because of their importance to them. But because of drought and other things, and including humans, which I'm going to come back to it in a second, they are now listed as threatened species, not fully endangered, but threatened species. So that is actually, we again have to think about that these species have been doing these things for hundreds of thousands of years or millions of years, but now things are changing, and climate change is one of the things that is driving it, and also humans directly. So they captured these moths, and they put them in sort of like they tethered them, and they looked for how their direction is going to be, and gave them a simulator in front. In some sense, they gave them the landmarks that are around it and the sky. Now, these are nocturnal, so they go at night. So they were trying to figure out, how do they find out where they are going? Do they see things, or are they sensing it through other things like magnetic fields? Now, of course, birds, they have nocturnal birds, they use Earth's magnetic field to do that. They also use stars. And monarch butterflies actually go a long distance, but they use the sun. They usually migrate during the daytime for a lot of things.
A lot of them around right now. And you got milkweed in your yard and you're experiencing them?
Right outside here, by the way. But they also use the Earth's magnetic field. So that's really crucial in there. So they put these moths in this simulator at the right time. And then they try to see, where are they going? How are they responding to that? And it turns out if you have the Earth's magnetic field, so they didn't change anything, they had this magnetic field in there. Without the stars, they could still use the Earth's magnetic field. But then they also put them in a chamber without magnetic field. And they tried to see, well, what happens to them? And they gave them simulated stars, in particular the Milky Way. And in the southern hemisphere, the Milky Way is quite prominent. And sure enough, they actually oriented themselves to north regarding the Milky Way's direction. And as you would imagine that a few months later, they come back to the same place. And so the Milky Way would be in a slightly different orientation. And that's what these scientists did, because in a simulator, you can actually change the orientation. It's like a planetarium, basically. You can change the orientation by 180 degrees of the Milky Way, and they would immediately change their direction of flying. So it was pretty clear that they are using the Milky Way. But to me, one of the cool things is they also simulated just random stars. So instead of the Milky Way, they put in sort of like stars of the same intensity distributed randomly in the sort of like simulated sky, and they got completely confused.
Oh.
And so it's such a cool, what I like about this is such a cool study in order to think about how do you rule out different things. Avi Loeb, for example.
Could be aliens that are directing these boson moths in Australia. That's what I'm going to leap to from number one, should be aliens.
So there are ways to rule out different types of things. And so this way, by removing the Earth's magnetic field, they knew that, okay, they could not be using the Earth's magnetic field. They are only using the stars. And then by changing the distribution of stars, they could tell that actually they use the Milky Way. And that's through evolution, because when they start their journey, they go to a place where they've never been. But they've been programmed in that sense to actually go in that direction and to use the Milky Way. Now, they also looked at, so one of the sort of like big things regarding that is this is the first time that scientists have found that invertebrates use the stars to go for long navigational paths. And so this is interesting. I mean, they have tiny brain. So it talked about sort of like, I was looking at it, that the moths themselves have a 2-inch wingspan. And I was looking at some stuff and I found footage that these moths actually also invaded the closing ceremony of the Sydney Olympics in 2000. And I found there is this opera singer who was singing, a legendary opera singer, Australian, and there was a big moth. So, I mean, they're doing pretty big. Land on her, up in there. And so these moths are still, but their brains are still tiny. They're the volume is a tenth the size of a rice grain. But these scientists figured when they had them in the simulator, they also had these tiny electrodes that they put into their brain and looked at how their neurons fire when they change the Milky Way direction to make sure and sure enough, their neurons are firing as when they are using the Milky Way, and when you change it, and it again fires again. So I just love this type of stories because it's, I think it takes, of course, a lot of care, but it's so cool that here you have this tiny, moths, which you go stupid moth going to the light and things like that, and annoyance factor and things like that. But here they are using their eyes because they're using visual cues to figure out where they are going. And they think they cannot their eyes are not sophisticated enough. I shouldn't say sophisticated. They just have different eyes, okay, to see individual stars. But the Milky Way is big enough that they think that they use the Milky Way to figure out their path.
And when we say the Milky Way, we're all in the Milky Way. We're looking at the edge of the cloud of the Milky Way, which in Western Massachusetts is not easy to see. But if you go into the hill towns away from the light, you can see it once in a while. The best place I've ever seen it with my own eyes is on Monhegan Island off the coast of Maine, which is this dark sky island. And while we were staying there, I was with my family, and we'd be out there, and speaking of the meteor showers that you can see Tuesday night and Wednesday night this week, we would see shooting stars all the time. And they were, wow, wow. And I'm like, no, look at the cloud of the Milky Way. It's right there. Well, it's not a cloud. It's stars. It's something we almost never get to see here. And the reason is light pollution. And, we have our friend James Lowenthal, who is an astronomer at Smith College, who's trying to work with the city of Northampton to diminish some light pollution. But this has greater implications than just our enjoyment of the night sky. If it gets too bright in Australia, these Bogong moths are going to be gone on the wrong trail.
Well, and in fact, it is directly related. But I should mention about when I was at the Cape last week, we actually went to the drive-in to see Superman.
Nice.
Good movie.
Yeah. I liked it.
Yeah. And that particular night, like sometimes in the ocean side when it's drier a little bit and you have really blue skies during the daytime and nighttime, you have crisp skies. So at the drive-in, yes, the movie was going on. I had actually seen it before in the theater, but but we went back. My wife had not seen it, but I was looking up in the sky because the Milky Way was really nicely lit up.
Wow.
And it was actually really good. You could actually see the darker spots in there, which I also love because that's where you are seeing dust blocking the light from the other stars in the back. So you can actually start seeing structure of our own galaxy, and we are looking into it. But the light pollution bit, one of the reasons why these Bogong moths are endangered is because of lights as well. So including the Olympic story that I told you where they ended up.
Got the torch. They're running with it. The moths all follow it along.
But was in Sydney.
Yeah.
And they're not supposed to go towards Sydney, but there are these huge lights over there. And so they see that as, well, this is the sign. I'm going to go towards the light. And so this is one of these issues that they get distracted by this, by sort of like these human lights. And
I mean, they are moths. They're famous for getting distracted by the human lights. Have you ever heard that Norm Macdonald joke?
No.
I will tell you. It's so funny.
But so these moths, one of the big, apart from droughts, which are going through because of climate change, the other factor is light pollution. Because they get things. Same thing with dung beetles when we talked about that, yes, they look for the Milky Way, but on the other hand, you have a brighter source of light coming from a city nearby. You go like, you know what? Hey, the brighter one, that's a better one. And then, of course, they die out in there. So light pollution is a serious threat. And it's not just about the moths. I mean, the problem is that, of course, they are part of the ecosystem. So there are other species that depend on them and things like that. So if one species die out, you are going to have, of course, a connection to other species as well. So yeah, I mean, I think we should appreciate next time you see a moth and you go like, hey, they look at the night sky. I mean, maybe not that particular one, but certainly the species of moths. And we, again, our sensitivity, our thinking about our environment in terms of lights, for example. So if you have lights that are just on without like looking up, for example, try to have a shade.
Yeah.
And if you don't need to have it on, don't switch it on.
Yeah.
Have
the lights off at night.
Have it on a timer.
It's good for the pollinators. It's good for the birds. And if you run a giant space company, maybe don't launch thousands of satellites into the night sky. I'm glad you're bringing the internet to the world, but you're also messing up the way the Milky Way looks to these moths and others.
And also the species of astronomers. Because they also cannot observe, like with a Rubin telescope. So I want to end on a positive note. Again, looking back at these moths, I mean, I think this is one of those stories where, again, the scientists actually came up with the ideas to test those things, and I think that is great. But on the positive side, or on the negative side, I should connect that story to New Mexico. I have seen sort of when I was used to go to the observatory over there in New Mexico. It's at Apache Point Observatory. And there would be telescope closures because of clouds, rain, and sometimes even dust storms. But I have encountered observatory closure because of moths. Because there would be so many moths sometimes that would come in. And if you leave the observatory slit open, they would come in and jam the wheels that moves the sort of like the dome and stuff like that. So we would have a closure in a season of moths where the telescope would be closed because of moths. And one time I was there, and New Mexico State, where I did my PhD, was about 2 hour drive from there. And so normally you would do the observing and then stay over there at nighttime and drive the next morning. And I went to the room, the dormitory room over there, and somebody had left the light on inside. And I opened the door, and it was covered with moths. Somehow moths had gotten in, and I decided, I think, I'm tired. I'll take the risk of the mountain, and drive back rather than sleep with a sheet on with moths all around you.
Yeah.
Maybe after reading this paper, I would say, you know what? There are fellow astronomers.
So like down the road like 100 yards and turned another big light on. Or, maybe turn the Milky Way, shine a light onto the Milky Way.
I look at them now as fellow astronomers. So I would be like, we are all together in this, on this planet, and we are all trying to figure out